Are we alone in the universe? Is Earth the only place in this vast universe where life has taken root? Or are there others out there, looking up at their own night skies, asking the same question? In the 20th century, our curiosity gave rise to a new era of exploration. We sent rockets into space, landed on the moon, and built telescopes that could peer deep into the cosmos. We began searching for signs of life beyond our planet, listening for signals from the stars, scanning distant worlds for traces of water, and dreaming of the day we might make contact with another civilization. But as our search has intensified, a strange and unsettling silence has greeted us. Despite the vastness of the universe, despite the billions of stars and planets that could harbor life, we have found nothing. No signals, no messages, no evidence of other civilizations reaching out across the stars. In 1950, physicist Enrico Fermi, in a moment of casual curiosity, posed a simple yet profound question: where is everybody? This question, now known as the Fermi Paradox, challenges us to reconcile the apparent likelihood of intelligent life elsewhere in the universe with the stark reality that we have yet to find any evidence of it. The Fermi Paradox is one of the greatest mysteries of our time. If the universe is so vast, so filled with potential for life, why haven't we heard from anyone? Is there something we're missing, some cosmic truth that eludes us? Or is the silence itself a message? A warning, perhaps, or a sign of something far more complex than we ever imagined? In this documentary, we will explore the Fermi Paradox in depth, examining the scientific, philosophical, and speculative theories that have been proposed to explain it. From the search for exoplanets and the possibility of the Great Filter, to the more speculative ideas of the zoo hypothesis and the dark forest theory, we will discuss the heart of the paradox that has left scientists and thinkers alike searching for answers. The search for extraterrestrial life is more than just a scientific quest. It's a journey of discovery, a search for meaning, and a challenge to our understanding of life itself. The question remains, where is everyone? Space, an endless expanse filled with countless stars, each one a potential cradle for life. But as we stare into the infinite, a question arises, one that has puzzled humanity for generations: where is everyone? To understand this enigma, known as the Fermi Paradox, we must first grasp the sheer vastness of the cosmos, a scale so immense it defies our comprehension. Our home galaxy, the Milky Way, is a swirling collection of over 100 billion stars, stretching 100,000 light-years across. If we were to travel at the speed of light, it would take us a century to cross just 1% of its breadth. But the Milky Way is just one of countless galaxies, each a colossal collection of stars, planets, and perhaps life. The universe we inhabit is unfathomably vast, far beyond the reaches of our imagination. The observable universe spans over 93 billion light-years and contains more stars than there are grains of sand on all the beaches of Earth. Imagine, within every galaxy, 1 trillion suns, and around those suns, countless planets, moons, and asteroids, each a potential home for life. And yet, in all this vastness, we find ourselves alone, surrounded by the silence of space. This is the heart of the Fermi Paradox, a contradiction between the high probability of extraterrestrial civilizations and the complete absence of any evidence for their existence. To grasp the magnitude of this paradox, we must first understand the numbers involved. How likely is it that we are truly alone in such a vast and ancient cosmos? In 1961, astrophysicist Frank Drake proposed an equation to estimate the number of active communicative extraterrestrial civilizations in our galaxy. The Drake equation considers several factors: the rate of star formation, the fraction of stars with planetary systems, the number of planets per system that could potentially support life, the fraction of those planets where life actually arises, the percentage of life forms that develop intelligence, the proportion of intelligent civilizations that can communicate across interstellar distances, and the lifespan of such civilizations. Given the vast number of stars and planets, the equation suggests that there should be millions, if not billions, of civilizations in our galaxy alone. Each star we see in the night sky could have its own solar system, complete with planets, some potentially teeming with life. And yet, we have found nothing. No signals, no probes, no signs of advanced civilizations reaching out across the stars. Our planet, teeming with life, is surrounded by a profound silence. As we venture further into space, this silence becomes even more puzzling. Where are all the other civilizations? Why haven't we encountered them? Is it possible that intelligent life is so rare that we are, for all practical purposes, alone in the universe? Or is there something preventing us from hearing their voices? The scale of the universe is so immense that it's hard for us to even grasp it. The distances between stars are so vast that communication across them would take thousands, if not millions, of years. Even with our most advanced technologies, the signals we send today will take centuries to reach the nearest star systems. But even with these vast distances, the absence of any detectable signals or evidence of other civilizations is perplexing. It's as if the universe is a vast, empty theater with no one else in the audience. For decades, we have been listening to the stars, hoping to catch a whisper from another world. We've scanned billions of frequencies, searching for anything that might indicate intelligent life. From the vast radio telescopes of the SETI program to the sophisticated algorithms of the Breakthrough Listen project, our quest for contact has been tireless, but the universe remains silent. Could it be that we are truly alone, or is there something more at play? The absence of evidence is not evidence of absence. Just because we haven't found anything yet doesn't mean there's nothing out there. The universe is vast, and our search has only just begun. We've only scanned a tiny fraction of the sky, and even then, we've only looked at specific frequencies. There could be civilizations using technologies we can't even imagine, communicating in ways we haven't yet discovered. As we continue our search, the Fermi Paradox looms large, a mystery that forces us to confront our understanding of life, intelligence, and our place in the cosmos. The question, where is everyone, isn't just about finding aliens, it's about understanding the nature of life itself and whether we as a species are destined to remain isolated in the vastness of space. Since the dawn of humanity, we have looked up at the stars, wondering if we are alone in the universe. It wasn't until the 20th century that we began to seriously search for signs of other civilizations. The quest to find intelligent life beyond Earth remains one of the most profound scientific endeavors of our time. An endeavor that has captivated the imaginations of scientists and the public alike. The search for extraterrestrial life began in earnest in the mid-20th century, when scientists first considered the possibility of detecting signals from distant civilizations. In 1960, the first modern SETI experiment, Project Ozma, began its search by scanning nearby stars for radio signals that might indicate intelligent life. Project Ozma, led by Dr. Frank Drake, was the first systematic attempt to listen for extraterrestrial signals. Using a radio telescope in Green Bank, West Virginia, Drake focused on two nearby stars, Tau Ceti and Epsilon Eridani, hoping to detect radio waves that might signify intelligent life. Although no signals were detected, this pioneering effort laid the groundwork for future SETI research. The idea of listening for signals from another civilization is extraordinary. It represents a profound shift in perspective, from seeing ourselves as the center of the universe to realizing that we might be one of countless civilizations spread across the cosmos. This idea drives the SETI community to continue its search despite the challenges and the slim odds. However, the search is fraught with challenges. The universe is filled with noise, natural radio emissions from stars, galaxies, and even our own planet. Distinguishing a potential signal from this cosmic cacophony is akin to finding a needle in a haystack. Even if a signal is detected, it could take years to confirm its origin and decipher its meaning. In 1977, a strong, unexplained signal was detected by the Big Ear radio telescope, known as the WOW signal. It was a brief but powerful burst of radio waves, unlike anything ever seen before. For decades, scientists have sought to explain it, but no conclusive answer has been found. Could this have been a message from an alien civilization, or was it an unexplained phenomenon? The mystery of the WOW signal remains unsolved, a tantalizing hint that we might not be alone. Today, the search continues with renewed vigor. Advances in technology have expanded SETI's capabilities, covering more of the sky and exploring a wider range of frequencies. New algorithms and machine learning techniques are being developed to sift through vast amounts of data, identifying potential signals that might otherwise go unnoticed. Optical SETI, which looks for laser pulses from distant civilizations, is also gaining traction. We are on the brink of a new era in SETI research. The tools and techniques available now are far more advanced than those of just a few decades ago. We are scanning the skies with unprecedented sensitivity and at an accelerated pace. Every day, we come closer to answering one of humanity's most profound questions. Are we alone? The James Webb Space Telescope, launched successfully in December 2021, is allowing us to peer deeper into the cosmos than ever before. With its incredible sensitivity, JWST can examine the atmospheres of distant exoplanets for potential signs of life, detecting faint biological signatures that might indicate the presence of advanced civilizations. One of the most promising avenues in the search for life is the study of exoplanets, worlds beyond our solar system. In recent years, astronomers have discovered thousands of these planets, many of which are located in the habitable zone, where conditions might be right for life. By studying the light that passes through these planets' atmospheres, we can search for biosignatures, chemical markers that indicate the presence of life. Imagine the possibilities: a distant planet, orbiting a star not so different from our own, teeming with life, perhaps intelligent beings looking up at their night sky and wondering the same thing we do. Are we alone? The discovery of such a world would be one of the greatest scientific achievements in history, fundamentally altering our understanding of the universe and our place in it. The search for extraterrestrial life is a truly global endeavor, uniting scientists from diverse fields and countries in a common goal: to answer the age-old question of whether we are alone in the universe. As technology advances, so too does our ability to explore the cosmos and uncover its secrets. The search for extraterrestrial life touches on some of the deepest questions we can ask. It forces us to confront our own significance in the universe. Are we a cosmic accident or part of a grand design? If we are alone, what does that mean for our future? And if we are not alone, how will that knowledge change us? These questions go beyond science. They speak to the very essence of what it means to be human. As we continue our search, we must also confront the possibility that we might never find anyone else out there, that we are, for all intents and purposes, alone in the universe. But even if we are, the search itself is a testament to our curiosity, resilience, and unyielding desire to explore the unknown. The question, are we alone, is not just about finding others, it's about understanding ourselves and our place in the cosmos. Life on Earth began nearly 4 billion years ago, in an environment that was anything but hospitable. Our planet was a fiery, chaotic world bombarded by asteroids and plagued by volcanic eruptions. Yet somehow life took hold. Simple, microscopic organisms emerged in the primordial oceans, and from these humble beginnings, all life on Earth evolved. But the journey from simple life forms to intelligent beings capable of building civilizations was anything but guaranteed. It took nearly 4 billion years for life to evolve to the point where it could look up at the stars and ask, "Are we alone?" Even then, the emergence of intelligent life was the result of a series of improbable events, cosmic coincidences, narrow escapes from extinction, and the relentless march of evolution. Throughout Earth's history, life has faced numerous challenges: mass extinctions, climate changes, and cosmic catastrophes. Each time, life has persevered, but the outcome was never certain. This raises a profound question. Is there a stage in the evolution of life that is so difficult to surpass that most civilizations never make it through? This is the idea behind the Great Filter, a concept that could explain why we haven't encountered any other intelligent civilizations. The Great Filter is a hypothesis suggesting that there is a barrier, or perhaps a series of barriers, that prevents life from reaching the stage of advanced civilization. This filter could occur at any point in the evolutionary process. It might be as early as the formation of simple life, or it could come much later, when a civilization begins to develop advanced technologies. The key question is, have we already passed this filter, or is it still ahead of us? If the Great Filter is behind us, it would mean that the emergence of intelligent life is incredibly rare. So rare that we might be one of the few, if not the only, civilizations to have made it this far. But if the Great Filter lies ahead of us, it could imply that our future as a civilization is far from assured. We might face challenges that, if not overcome, could lead to our own extinction. The idea of the Great Filter compels us to confront uncomfortable possibilities. If we are alone in the universe, it might not be due to our uniqueness, but because the path to becoming an advanced civilization is fraught with dangers. Dangers that most civilizations fail to survive. It's a sobering thought that our future might hinge on decisions we make today, decisions that could determine whether we pass through the filter or fall victim to it. In the modern world, we face a number of existential threats that could represent the Great Filter for our civilization. Nuclear war, climate change, pandemics, and the rapid advancement of artificial intelligence all pose significant risks. These are challenges that demand global cooperation, foresight, and a commitment to ensuring the survival of humanity. The challenges we face today are unprecedented, but they are not insurmountable. We have the tools and the knowledge to address these threats, but it will require a concerted effort from the global community. The key to navigating the Great Filter, if it lies ahead of us, will be our ability to work together, to prioritize long-term survival over short-term gains, and to make wise decisions about the technologies we develop and deploy. If we can navigate these challenges, we may pass through the Great Filter and continue our journey as a civilization. The search for extraterrestrial life is not just about finding others. It's about learning how to ensure our own survival. By understanding the risks and working together to mitigate them, we can increase our chances of passing through the filter and becoming a truly advanced civilization. The Great Filter challenges us to think deeply about our future. It reminds us that while the universe is vast and full of potential, our survival is not guaranteed. But it also offers hope. Hope that we can learn from the challenges we face, hope that we can pass through the filter, and hope that one day we might find others who have done the same. The concept of the Great Filter underscores the importance of making wise decisions about space exploration, technology, and our stewardship of Earth. It's not just about avoiding existential threats. It's about preparing for a future where we might reach out to other civilizations. We have a responsibility to ensure that we do so as a mature, responsible civilization, one that has learned from its history and is ready to take its place in the cosmos. As we look to the stars, we are reminded of the fragility of life and the responsibility we bear for its continuation. The Great Filter is not just a scientific hypothesis, it's a call to action, a reminder that the future of our civilization is in our hands. The decisions we make today will determine whether we pass through the filter and reach the stars, or whether we fall victim to the same challenges that may have claimed countless civilizations before us. Imagine, for a moment, that we are not the observers but the observed. Somewhere out there, advanced civilizations might be watching us, much like we observe animals in a zoo. This is the essence of the zoo hypothesis, a provocative idea offering one possible explanation for the Fermi Paradox. Could it be that we are part of a cosmic experiment, monitored and deliberately isolated from the rest of the universe? The zoo hypothesis suggests that advanced extraterrestrial civilizations might have discovered us but chose not to make contact. Perhaps they consider us too primitive for interstellar communication, or view us as an experiment, observing our development from a distance, much like we observe animals in their natural habitat. The notion that we might be observed by advanced civilizations is both unsettling and fascinating. It prompts us to reconsider our place in the universe. If the zoo hypothesis is correct, it could imply that we are not alone, but that we are being deliberately kept in the dark, shielded from the broader galactic community until we achieve a certain level of maturity. But why would advanced civilizations choose to observe us in secrecy? Some theories propose that these civilizations might adhere to a non-interference policy, a cosmic prime directive, if you will. They may believe that direct contact could disrupt our natural development, much like a human observer might avoid interacting with animals in a zoo to prevent altering their behavior. The zoo hypothesis parallels our own practices of observing less technologically advanced cultures. In anthropology, we strive to observe without interfering to better understand the natural progression of a society. It's conceivable that an advanced extraterrestrial civilization might adopt a similar approach, observing us from afar rather than risking alteration of our development. If the zoo hypothesis is true, what might happen if we discovered our observers? Would they reveal themselves or retreat further into the shadows? The possibility of being watched raises profound questions about our autonomy and future. However, the zoo hypothesis is just one of many theories attempting to explain the Fermi Paradox. There are other, even more speculative ideas that challenge our understanding of the universe. One radical idea is the simulation hypothesis, the notion that our reality might be an artificial construct, a simulation created by a far more advanced civilization. If true, the reason we haven't found other civilizations might be because they don't exist, or because they are beyond the simulation, outside our ability to perceive. The simulation hypothesis suggests that our universe could be a digital construct, much like a highly advanced video game. If this is the case, the limits of our understanding might be built into the simulation itself. The absence of other civilizations could be a deliberate design choice to keep us focused on our own development, or a reflection of the simulation's programming limitations. While the simulation hypothesis remains speculative, it raises fascinating questions about the nature of reality and our place within it. If our universe is a simulation, then the search for extraterrestrial life might be futile, a quest for something that exists only outside the bounds of our simulated world. However, there are more conventional theories grounded in the physics of our universe that could explain the Fermi Paradox. Another theory is the dark forest hypothesis, which suggests that the universe is a dangerous place, filled with civilizations that remain silent out of fear. In this view, the cosmos resembles a dark forest, where every civilization is a hunter hiding to avoid detection by others. The reasoning is straightforward. In a universe with limited resources and scarce trust, the safest strategy is to remain hidden to avoid attracting a more powerful predator. The dark forest hypothesis is based on the idea that in a universe filled with potentially hostile civilizations, silence is the best defense. Any signal sent into the cosmos could be intercepted by a more advanced and powerful civilization. In such a scenario, the logical choice is to remain quiet to avoid detection and minimize the risk of conflict. If the dark forest hypothesis is true, it could explain the silence we observe in the cosmos. Perhaps countless civilizations are out there, all hiding in the shadows, each aware that revealing their presence could invite disaster. In such a universe, the greatest threat to any civilization might be its own curiosity. There are many other theories that could explain the Fermi Paradox. Some suggest that advanced civilizations may have transcended physical existence, becoming beings of pure energy or consciousness. Others propose that civilizations might exist in other dimensions, invisible and inaccessible to us. There is also the possibility that life is so rare we are, in fact, alone, a solitary spark in an otherwise lifeless universe. The Fermi Paradox challenges us to think about the universe in new ways. It compels us to confront the limits of our understanding and question our assumptions about life, intelligence, and the nature of reality. Whether the answer lies in the zoo hypothesis, the simulation hypothesis, the dark forest theory, or something else entirely, one thing is clear: the universe is far more mysterious and complex than we ever imagined. As we explore these theories, we are reminded that the search for extraterrestrial life is not just about finding others, it's about understanding our own place in the cosmos. The Fermi Paradox remains one of the greatest mysteries of our time, challenging us to look beyond the known, consider the possibilities, and keep searching, no matter how elusive the answers may be. As we gaze into the cosmos, we are reminded that the search for extraterrestrial life is far from over. In fact, it's only just beginning. With each passing year, our technology advances, our understanding deepens, and our ability to explore the universe expands. The future of the search holds immense promise that one day we might finally answer the question that has driven humanity for centuries. Are we alone in the universe? In the coming years, new technologies will revolutionize our search for extraterrestrial life. The James Webb Space Telescope, with its unprecedented sensitivity, is already providing insights into the universe that were previously beyond our reach. It examines the atmospheres of distant exoplanets for potential signs of life, offering new possibilities in our quest. The Square Kilometre Array, the world's largest radio telescope, will soon begin scanning the skies with unparalleled precision, searching for faint signals from across the galaxy. We're on the brink of a new era in space exploration. The tools we're developing now will give us the ability to detect biosignatures, chemical markers in the atmospheres of exoplanets that could indicate the presence of life. We'll also be able to detect technosignatures, artificial signals or structures that could be evidence of advanced civilizations. The possibilities are incredibly exciting, and the discoveries we could make in the next few decades could change our understanding of the universe forever. One of the most promising avenues in the search for extraterrestrial life is the study of exoplanets, worlds beyond our solar system. With thousands of exoplanets already discovered and many more likely to be found, scientists are focusing on those that lie within the habitable zone, the region around a star where conditions might be right for life to exist. By analyzing the light from these planets as it passes through their atmospheres, we can search for biosignatures, gases like oxygen, methane and water vapor, which are often associated with life on Earth. The discovery of biosignatures on an exoplanet would be one of the most profound discoveries in the history of science. It would suggest that life is not unique to Earth, and that it could exist in many forms across the universe. However, we must be careful in our interpretation. Biosignatures could have non-biological explanations, and it will take time and further study to determine whether they are truly indicative of life. But the potential is there, and it's a thrilling prospect. While the search for life on exoplanets continues, we must also explore the potential for life closer to home, within our own solar system. Moons like Europa, Enceladus and Titan are among the most promising candidates. Beneath their icy surfaces lie vast oceans of liquid water kept warm by the gravitational forces of their parent planets. These oceans could harbour microbial life, similar to the extremophiles found in Earth's deep oceans and hydrothermal vents. The exploration of these icy moons is one of the most exciting frontiers in astrobiology. Missions like NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer, will provide us with detailed maps and data about these moons, paving the way for future missions that could drill through the ice and explore the oceans below. If we find even the simplest forms of life in these alien oceans, it would have profound implications for our understanding of life's potential in the universe. In the coming decades, our robotic explorers will venture further into the solar system, seeking out new frontiers and searching for signs of life in places we've only just begun to explore. Mars, with its ancient riverbeds and signs of past water, remains a top priority. The Mars Sample Return mission will bring back rock samples from the Martian surface, potentially containing evidence of past life. Meanwhile, missions to asteroids and comets will provide insights into the building blocks of life and the origins of our solar system. The future of space exploration is not just about government-led missions. It's about a new era of collaboration between the public and private sectors. Companies like SpaceX, Blue Origin and others are pushing the boundaries of what's possible, with plans to establish human colonies on Mars, mine asteroids for resources, and even develop interstellar spacecraft. The search for extraterrestrial life will be a key part of this new era as we explore the solar system and beyond, searching for signs that we are not alone. As we look further into the future, we can imagine a time when humanity is no longer confined to Earth. With the development of advanced propulsion technologies, we may one day send probes to the nearest star systems, such as Alpha Centauri, in search of habitable planets and intelligent civilizations. These missions, though decades or even centuries away, represent the ultimate goal of our search for life beyond Earth, a goal that could reshape our understanding of the universe and our place within it. The idea of interstellar travel and contact with other civilizations has long been a dream of science fiction, but it's a dream that could one day become a reality. As we continue to advance in our understanding of physics and technology, we may discover new ways to traverse the vast distances between stars, opening up the possibility of communication with other intelligent beings. The implications of such contact would be profound, challenging everything we know about life, intelligence, and the nature of the universe. As we continue our search, we must remain open to the possibility that the answers we seek may not come in the form we expect. The universe is vast and mysterious, filled with wonders beyond our imagination. Whether we find other civilizations or discover that we are truly alone, the journey itself is a testament to our curiosity, our determination, and our enduring desire to explore the unknown. The discovery of extraterrestrial life, whether it's microbial life within our solar system or intelligent civilizations beyond, would have profound implications for humanity. It would challenge our understanding of ourselves, our place in the universe, and our responsibilities as stewards of life. As we continue our search, we must consider the ethical implications of our actions, ensuring that we approach this quest with humility, respect, and a sense of shared responsibility for the future of life in the cosmos. As we look to the stars, we are reminded of the fragility of life and the wonder of existence. The search for extraterrestrial life is not just a scientific endeavor. It is a journey of self-discovery, a quest to understand who we are and what our place is in the grand tapestry of the universe. Whether we find others or not, the search itself is a testament to our humanity and to our unyielding desire to explore, to learn, and to connect with the cosmos. As we conclude this journey, we return to the question that has been at the heart of our exploration: where is everyone? In our search for answers, we have uncovered deeper questions about life, intelligence, and our place in the universe. The silence of the cosmos is a profound mystery, one that forces us to confront the limits of our understanding and the vastness of the universe. Whether we are truly alone or one of many civilizations spread across the stars, the journey to find the answer is as important as the answer itself. In seeking others, we learn more about ourselves, our hopes and fears, and our relentless drive to explore. Throughout our journey, we've explored the possibilities, the search for life on distant exoplanets, the potential barriers that might prevent civilizations from reaching out, and the theories that challenge our very understanding of reality. Each of these ideas offers a glimpse into the complexity of the universe and the challenges we face in our quest for knowledge. As we look to the future, we must remain committed to the search, not just for extraterrestrial life, but for understanding, for meaning, and for our place in the cosmos. The tools we build, such as the James Webb Space Telescope and the Square Kilometre Array, the missions we launch, like those to Mars and the icy moons of our solar system, and the discoveries we make will shape our destiny as a species. The universe is vast, and our journey has only just begun. The Fermi Paradox remains unsolved, but the quest to understand it has only deepened our appreciation for the universe and our place within it. In the silence of the cosmos, we find not despair but hope. A hope that one day we will discover the answers we seek, and in doing so learn more about ourselves and the wondrous universe we call home. Thank you for joining us on this journey. The Fermi Paradox is a challenge, but it's also an invitation. An invitation to keep exploring, to keep questioning, and to never stop searching for the answers. Whether we find life or not, the search itself is a reflection of our deepest desires, to connect, to understand, and to transcend the boundaries of our knowledge. Every step we take, every discovery we make, brings us closer to understanding the true nature of life in the universe. It's a journey worth taking, no matter where it leads. The future is full of possibilities. As we continue to explore the cosmos, we must remain open to the unknown, ready to embrace whatever we may find or not find out there. The Fermi Paradox remains unsolved, but the quest to understand it has only deepened our appreciation for the universe and our place within it. In the silence of the cosmos, we find not despair, but hope. A hope that one day we will discover the answers we seek, and in doing so, learn more about ourselves and the wondrous universe we call home. Thank you for joining us on this journey.